Alright, good morning and welcome back to another video. And in today's video we're going to look at for loops and how to program those. So let's get started here. So a loop is a repetitive structure. So if you're repeating calculations multiple times, you want to use a loop. Alright, so first thing is I'm going to assign capital N equal to 10, and that's going to be the loop indicator. How many times we're going to do the loop. And how do you program a loop? Well, you're going to say for I equals 1 colon n. And then we're going to say y of I equals I times 2. So some random equation. Let's say plus n and then end. Okay, so you always start the for loop with for space a variable. It could be lowercase n or I, it doesn't really matter. It could be anything. Then equals 1 colon n. That means we're going to start at 1 and we're going to go to 10. So we're going to, basically it goes by ones every time. Okay, let me just change it back to I. And then here inside the loop, I want to store y. I want to make it a matrix. So I'm building this matrix. So y of 1 equals 1 times 2 plus n. Now again, this is some random equation just to show you how the loop works. Okay, so it's gonna basically put 1 in here, 1 in here, and then this is 10. Then it's gonna come back up, change this to 2. I is now 2, so this will be 2, and this is 2 times 2 plus 10. Come back up, I is now 3. This will be y parenthesis 3. Then it's 3 times 2 plus 10. And it's going to keep doing this until you have y of 10. So if I do this, if I say pause, let's see if this works, and I run this, let's save it on the desktop. And I believe it's tutorial 8. 8. Change directory and go to your command window. So y is 12 because it's I is 1. Actually, let me show you. Let me hit Control C. Control C will stop the code or stop the loop in our command window. Let's go back to the editor and let's do this. Let's say I, just to show you. So I put I in there, run it. Back here. So I is 1, y is 12 because it's 1 times 2 plus 10. Now I paused it just to show you. So I'm going to hit enter. I is 2. Now y is actually two numbers, 12 and 14. Okay, if I hit enter again, I is 3. We get 3 numbers for y, and it's 12, 14, 16. Why is it 16? Because it's 3 times 2, it's 6 plus 10. Okay, so it's going to keep doing this. 8, 9, 10, and then it'll stop. Okay, so y should have 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now if we type y, it's now built. This is our matrix. It's a row, one row with 10 columns. All right, so technically we don't need that. We don't need that. And we don't even need this. And we just run it, and boom, we have y. Okay, cool. So that's one example, just to show you. Okay, so let's do another example here. I'm going to copy and paste some of this. Let's do it right there. Okay, so say we have 1, 2, 3, 4 grades. Our count is 0. It's just a loop counter. Okay, and then I'm going to do the loop. You're going to see this, and I'm going to do it the length of this. So it's going to do 1, 2, 3, 4 times, because this cool little feature, length. So for k equals 1 to n, and let's just clear all and CLC all. so we can start fresh. And then we're going to say if scores of k is greater than 90, count equals count plus 1. End and end. Oh, end. Okay. So what we're doing is we're doing an if statement in a for loop to check each one of these grades to say, okay, how many are actually above 90? So if I run this right now and I look, let's just go up to here and say count 2, which is correct because there's only 2 above 90. Now I can change this. I can do 87, 91, 90. I can do 99. And it should give us 1, 2, 3, 4. So if I go back to here, boom, because it's greater than 90. If we put an equal sign right here, right, greater than or equal to, then it would count the 90. Cool. All right. And say I wanted to correctly spit that out to the command window, that I use fprintf. Count is 2.1% or percent 2.1 f, and I'm just going to take that out, count. So if I run it, go to my command window, this now says the count is 4.0. Okay. Remember, this is the number of decimals. This is this total, like, thing. Actually, we could do 3, because if I go back, that's 1, 2, 3. If I did 4, there'd be an extra space here. Watch. If I run it, see how it created an extra space because it's 1, this empty space. The 4 is 2, the dot is 3, and then this 0 is 4. Cool. This length is used a lot. Okay. So just to recap this problem, we have a bunch of scores, and we created a count, or a loop counter. We said we're going to do the loop the number of times that scores is, okay, because we put length. So for k equal 1 to n, we're going to do this how many times? We're going to look at each score, and we're going to see if it's greater than 90. If it is, we're going to add a count. And then this if statement ends with an end, and this for loop ends with an end. Cool. Cool. All right, let's get right into an example, an engineering example here. Oh. Okay. So clear all and CLC. Okay. Here's a projectile motion problem. So AY is negative 9.81. We have 2 angles. So we're going to shoot a ball at 2 different angles, 15 degrees and 30 degrees. We have an initial velocity of 15, initial x of 0, and initial y of 0. And here is our time matrix. It's going to go, we don't need it to be that accurate, by 0.1s to 60 seconds. So picture yourself, you have a ball, you're going to throw the ball at 15 degrees and 30 degrees, and we're going to actually plot the trajectory. Okay, so what we're going to do is we're going to actually do 2 loops just to show you that you can do nested loops. So the outside loop is going to be for the different angles, and the inside loop is going to be used for time. Okay, so let's start the loops. So for I equal to 1 to length of theta. So we're going to do first, the outside loops are for the different angles. So we're going to do 15 degrees first, and then inside the calculations, let me hit enter. Okay, inside here, we're going to put the calculations. So this inside loop is going to be 1 to length of t. Okay. All right, cool. Well, we need to calculate velocities in the x and the y, and these are just equations. It's just Vx equals V naught cos d, because we're using degrees, theta of I, okay, because wherever you have theta here, you want to use this loop indicator, and Vy is V naught sine d, again, degrees, theta of I, okay. So far we're just calculating Vx and Vy, and these could actually be put in here, okay, but I just stuck them here. It's not a big deal. And now what we're going to do is, let me do the x first. Oh, sorry, that didn't copy right. Copy, paste. What we're going to do is we need to create a big matrix that's x of I comma j equals x naught plus Vx, which we calculated here, times t of j. And again, this is just a generic equation to solve for the position of the ball in the x direction given theta and an initial velocity in time. Okay. Now, how does this work? Well, first what's going to happen is I is going to be 1 the length of theta, which is actually 2. So I is either going to be 1 or 2. When I is 1, it's doing 15 degrees because it's theta of 1, which is 15 degrees. So I is 1, this is going to be 1, but j here is going to go from 1 to length of t, which is a lot of decimal points here. Okay, or a lot of like, it's well, say we did this 0 to 1 to 60, it's going to be like 61. It's going to go from 1 to 61 because we have a 0 here. Okay, so the first row, and I'll put it here, x of 1 comma colon, that's going to be basically your 15 degrees. Okay, because this corresponds to the first row. So once this loop is done, the first entire row, and I'll show you, is going to be based on 15 degrees. Okay, because this is going to be 1, and then this is going to change from 1, it's going to be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the way to 60. Okay. All right, well, what's the equation for y? This is the equation for y, which involves y naught, Vy times t plus 1/2 at squared. Okay, and again, these are just equations governing projectile motion for different angles. Okay, but here what we're doing is we need to do I again, I comma j, because this is going to be our 15 degrees when I is 1, when I is 2 it's 30, and then j is going to go from basically 1 to 60, okay, or 61 in this case. So let me delete that and let me run it. Okay, so if I type x, do you see how I can't zoom up, you see how it's 2 rows but 61 columns? So the top row, all right, so if I do x 1 comma colon, that first top row is all the x for 15 degrees. If I do y comma colon, that is all of the y values for 15 degrees. Okay, so if I type x in again, we got 2 rows, 61 columns, and it corresponds to the first row of 15 degrees, second row of 30, and each column corresponds to the different time intervals. Okay, cool. So now say we want to plot. Oh. Where to go here? Hit the wrong button. Okay, let's plot the solution. So we're going to first plot theta for 15 degrees. So if I run it, boom, here's my plot. Okay, this plot's x versus y. Okay, and say we want to plot theta 30 degrees. Well, then it's 2. And I did my axis. I'll show you this in a second, okay? And I'll show you the legend. So, again, we've done plotting before. All right, again, we're plotting the first row of x and y because it's 15 degrees. It's black line and it's a line width of 2. We're holding on so we can then plot the second row, which is 30 degrees. We labeled our x, our y. We identified our axis limits, so 0 to 30, and then y naught, which is again 0, and then 6. We just put those in. If we want to add a legend, the first line would be 15 degrees, second line is 30, and I'm not sure if this, oh yeah, okay, I see. Oh. We can manually type in the legend, or we can say num to string of theta of 1, or num to string theta of 2. That's just kind of how it's going to grab 15, put our grid on, and our title. So let's run this. So let's make sure we got some stuff right. So x is 0 to 30, y is from 0 to 6. Okay, we got our legend. All right, we did not see, whoops, sorry. Let me get the graph back up. So 15 degrees must not show up. So let's make our, let's see how choppy it looks. It's because we're going by 1 second. So if we change this 0.001 and we run it, it may take a little bit. Yep, probably. Computer's probably a little slow. That's a lot of data points. Let's kill it. Control C. Let's just go by 0.1. There we go. Oh yeah, much better. So the reason the black line, the 15 degrees didn't show up is because we were missing a lot of data points. Right? The time it takes is like we had going 1 second. It might not even been 1 second. So if I go 0.001, it's a little bit, we're going to get a little bit, oh yeah, look at these graphs now. Look at that. So again, this black line is 15 degrees, the red is 30, and it looks like we get like 12 here and about 20 meters in the X when we do 30 degrees. And the cool thing is you can change, say we want to do 45, we add 45 here. The only thing you need to change is in here. That's the only thing because we didn't hardwire anything. So this would be of 3. Oh, and we forgot the plot. Oops. Forgot the plot. Let's do it right here. Plot 45 degrees. But that's easy, right? Just copy, paste, change this to 3, and run it again. So sorry, there was a few things, 3 things, right? Ooh, look at that. Let's make that blue. And again, we don't have to put hold on because we already set it once. Ooh, look at that. Look at that graph. Cool. Cool. All right, just to recap. So here we did, the last problem we did was projectile motion. We had some givens, acceleration due to gravity. We did 3 different angles in this case, initial velocity, x naught, y naught, and our time matrix. Okay. Cool thing is we can just change these angles. We can change this. So say we went to 20. Okay, we can rerun it because it's not hardwired anymore. The only thing it's hardwired is for 3. Now it's out of our graph. We just have to change that a little bit. But say we did 10. There you go. Cool, huh? And then what we did here is we did 2 for loops, a nested for loop. So the outside for loop used the theta. So we did 3 different lines in this case, where the inside loop is time. So we're looping, we're basically doing a for loop, and we're putting in the time matrix inside here. Okay, so you need, anytime you have theta, you're going to do parenthesis I. Anytime you see t, it's going to be parenthesis j, because you need to grab that t value at that specific location. Okay. So, and again, we put I comma j because this is creating a matrix that's combining thetas and time. Cool. All right. Well, if you have questions, let me know. I hope this helps, and the more practice you do, the better. For loops aren't easy, but you'll get the hang of them. All right. Thank you very much, and have a good day.